2005 Junior Cert Higher Level Question 4 on developments. Have a quick look at this question. So the figure shows the elevation of a sculpture based on, and I'll just get a colour here, based on a cone A and a truncated cylinder B. Truncated, really important there. The cone and cylinder are in contact with each other. Okay, we'll have to have a think about that term after as well. Draw the given elevation and project a plan. So draw exactly the given and project your plan. Draw a development of the curved surface of the truncated cylinder. There's not a lot of drawing this. It's actually quite a nice question here. Seeing this initially, I was expecting that you'd have to draw your development of the curved surface B and of maybe the cone A. So it's not actually a bad question. Shouldn't take too long to go through this. I'm going to start off and just do exactly as they said. The cone and cylinder are in contact with each other, so I'm going to have to find the projections of all of the contact of them and find exactly how they're in contact and have a chat about that, and then draw the given elevation and then project a plan. So I just need a little bit of space underneath for a plan. I'm going to keep my drawing actually fairly far down my bottom left of my page. The cone is 90 mil in diameter, so the plan is going to be 90 mil in total. I leave about 20 mil under the plan, so that's 20 and 10 above it, so that means I want to go up 120 mil to find my XY line. So up 120 to get started on this one. So bottom left side, up 120. And I'm going to just come in 70. Now I'm going to actually, even though I planned on starting with the elevation there, I don't ever want to break one of my own rules, and that is, you always start by drawing the circle first and then project from the circle. No matter what the object is, draw the circle first. I want a 10 mil space between the views. I'm going to come down 55 mil there, down to 0, and then mark it back up to the 45. So there's my radius of my base circle of the cone. So I need to keep this relatively light because I know that part of it is going to be covered by the cylinder. But as I said there at the start, and I just, or just a minute ago, I don't want to measure 45 mil left and 45 mil right and try my best in after to make sure they line up. You start off by drawing the circle, and then you project your points from the circle. So it's just so much more accurate, it's quicker, it just ensures that we never have an error building up there at such an easy point in the drawing. The elevation is, how tall is that? It is 80 millimeters up here, and that can be drawn in as continuous finished line because there's nothing overshadowing that. Now, there we go, there's our cone drawn. Just to have another look at this, so we're onto our cylinder B. The cylinder is diameter 60. It doesn't give us an exact height to the center or to this point, but it does give us a little indication that the 80 mil high cone right here is the same height as the outer point of the cylinder. The cylinder is lying in contact with the cone, so the angle here is going to be 90 degrees. That's all I need to keep in mind. What I'm going to do is this. I'm going to just use my sliding set squares. I'm going to set up in line with the object. I'm going to run off. I'm just going to pick from the apex. It doesn't really matter where I pick actually. Run off perpendicular. It's 60, so I'm going to go ahead and I'm going to mark 60, but I'm also going to just mark 30. I'm going to go parallel to the side again. And I'll go up to my 30. And I'll draw it. I'll keep all this light now at the moment. I'll draw it right down through. And I'll go up to my 60. And draw it light. Right down through. I need to extend that now just a little bit. So that is basically the center line and the extreme right hand side generator of the cylinder right there. I'm going to set it now at the exact height that I've been asked to set it at, and that is in line with the apex. And I'm going to go back and draw the base once again. So a bit of constructing, a bit of messing about to do here really at the very start for this one. That's the original angle of the side. And the base of the object is at 90 degrees to that. There. So there's again like a little bit of thinking and figuring out involved in that now. So you'd have to have your little bit of knowledge there, I suppose, of solids and contact might help. But also there's our normal and our measurements stepped off as well. Now there's the two objects in contact. Before I do any more now, I just want to, I'm not going to worry about developments or anything yet. I need to go down to plan and find what this object looks like. So the first thing to do in plan is, let's find this point where it comes in contact with the cone. And that is going to be right there. I'm going to just call that point 1. As you might have started to realise, maybe like, you know, it's like right back to the basics. If you're looking at a circle, it appears as a circle, but if you just turn your viewing angle or turn the object, it appears as an ellipse. So for our ellipse, we need all of our 12 points. 1 is here. I'm going to go for 2 and 3 at the back, and then number 4. I'm going to go 5, 6, and 7. 8, 9, and 4, 10, and this is habit really, isn't it? 11, 12, and back to 1 again. Number 7 is on the extreme right hand side over here, which is also along the center. There's number 7. And then number 4 and 10 have to be the same as the radius, or sorry, the diameter of the cylinder. So I know that for 4 and 10, the cylinder is here at a radius of 30 mil out from the center. So from the center, is that the correct center? Sorry, no, I'm just about to make a little mistake. I was 4 and 10 there, projected down the plan, and from the center of that projection line. So where 4 and 10 came down to plan, I'm going to measure, scribe out 4 and out to 10. Now that gets me kind of well started. I'm going to have a freehand ellipse around here. 1, 2 is missing, 3 is missing. That's point 4. 5 and 6 are missing. I have 7, 8 and 9 are missing. I have 10, 11 and 12 are missing. Time to go and find them. Now, for our ellipse here, we're going to need a view that shows the ellipse as a circle. What I'm going to do is I'm going to add a little auxiliary view onto this, or a little extra view. I'm going to look up, along, in line with the axis of the object. If I use sliding set squares once more, in line with the axis of the object, which is also parallel to the edge of the cone. And I'll just grab the color here, and I'm going to project up through the center. I'm going to project up 0.7 on the outside and 0.1 on the inside. And I'm going to just need a position to start. Now, up there in that view, as we look straight in at the object, it appears as a perfect circle. So let's draw it. What do we get? We have a 0.1 here on this side. We have point 2, 3, and that's point 4 at the back, 5, 6, and point 7, 8, 9, point 10, 11, and 12. I'm going to use, again, all down to sliding set squares here. I'll set up in line with the main axis of the object. I'll bring it back, and I'm going to start breaking this guy up. Probably going to have to move away a little bit with this now, or I'll get caught. Now, there we go. We get point 1. There's 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, and back to 1. Again, I'm going to draw just in a different color here. I might just use a green for this. I'm going to bring all of those points and I'm going to make them a line along the surface. So if we just see that originally here, let's just say at point, what's out the front, number 10. The line number 10 is there. That's the whole line, and it starts here at point number 10 because there's going to be another profile along the ground that I need after. The line 7 goes all the way from the top down to the bottom as well. I won't draw them in yet though, but I'm going to just bring all of those points projected. So these are my divisions of the circle right now. I'm going to bring all of those. So there we have 2 and 12. I might bring them in pencil first as far as the object, and then just in my green pen from there. So that is 2 and 12. I have my 3 and 11. Here. 3, 11. 4 and 10 is already done. 5 and 9. 5 and 9. Finally, 6 and 8. That's 6, 8. Now what we need to do, we need to get all of those points down in plan, and we need to find out what the corresponding widths are. First thing I'll do is I'll just project them all down to plan, so I won't worry about widths or anything just as of yet. 6 and 8, 5 and 9, 3 and 11, 2 and 12. If we look at what we've been doing so far, I have a center line along 1 to 7 right here, and the width out to 4 and out to 10. If we just have a look at what we can correspond here and what links we can make. The center line from 1 to 7 lies across here. The width out to 4 and out to 10, out to 4 and out to 10. And if I can do that for those 2 points, well, I know that I can take the width here up to 5 and out to 6, and I can take it out the opposite way, out to 8 and 9. So all the widths can come from this auxiliary view up here. Now what we'll find as well is, if we're kind of thinking about this, that if I take the distance out to number 6 there, that's the same as number 8, which is the same as number 12, which is the same as number 2. So 2 and 12, which is here, 2 and 12, is the same as 6 and 8. Similarly, number 3 and 11 is the same as, which one is that, 9 and 5. So we get 5, 9, we get 3, and 11. That gives us all the points we need for this top part of the curve. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1. And we go ahead and join the dots. So that auxiliary view above that shows our circle will give us all the widths we need to establish this freehand curve in plan. The next thing then we'll need to understand, I suppose, is that first off, before I do move on, I can just heavy in what needs to be heavy here for this circle, and then I'm going to be working on, that is the bottom profile. This is the top profile as I look down on this truncated cylinder right here, and then I need the bottom profile where it stretches all the way along here and intersects the ground. As I said, before I do that, I'm just going to add a little bit of detail here, so I'll just lighten off my circular profile a little bit, and I will set my compass once more. And add in my hidden detail. Now, the green lines is what comes next. What I want to do now is I want to say, right, well, point 10 right there goes out someplace. How far out does it go? Well, it goes all the way down along the green line until it hits the ground here. So that right there becomes point 10 on the floor, on that profile. Point 4 is the same. Point 4 goes to the exact same position. That is the extreme back edge and front edge of the object. The furthest point is point number 7, which goes out as far as here. And that's not going to be an edge at all because it's just a line on the curved surface. That's point 7. I'd like to find everything now between 4, 5, 6, and 7, 8, 9, and 10, so that I have my outline. So 5, 6, 7 is done, 8 is out here, and 9. So 6 and 8, 6 and 8, and then 5 and 9. And what we'll find is that we get those points right there. And we can draw a freehand profile in here. The final part of this job is the rest of the profile. I've only gone out and back halfway. It has to go all the way in as well, which is going to be under the object. So, hidden detail. The first one that's already found is number 1. It's here, touching the edge right there at number 1. I'm going to need number 2, 3, and I'm going to need 11 and 12. So 3 and 11, 2 and 12. Now if you're comfortable enough with this, do what I'm doing, project them all and then follow your points after. We have point 1, point 2, and 2 pencils can often help here as well. Point 2 is over here someplace, point 2 is down here. So we get a point number 2. 3 is, where's 3? Sorry, 3 is along this line someplace, and then 3 goes down here. 3. Point 11 is along this line someplace here, and then point 11 there. And finally point 12 along this line, and then that's going to be in line with 2 here. 12. So from 1 to 12 to 11 to 10 all in hidden detail, and from 1 to 2, 3, and to 4, all in hidden detail. And that is the plan. So the elevation and plan of the object finished right there. Now I'm hoping I'll have enough space for this, but I'm not sure at all. I'll give it a go, we'll see. I'll fit most of it on my page anyway and get through most of the detail. If I just have it for this is for part B of the drawing. So part A, draw the given elevation and project the plan. The cone and cylinder are in contact with each other. That's it. That's all done. Part B, draw the development of the curved surface of the truncated cylinder. That means there's no need for a base on it or a top on it or anything like that, because they're flat surfaces. The curved surface is this whole surface that wraps around the object. First of all, I want to recognize the axis of the object, and if I have an axis, and if this is a right object, so there's my central axis through the object. And if you want a development of an object that has an axis, well, when it's a right object like that, and when it's not a cone or a pyramid, when it's a right object like this, look perpendicular to the axis and we can find our development. Everyone would get this if it was just laid straight down the ground, because we'd see that that was along the X and Y line. These are the ones that we started off with, let's say the ones we're used to. But if I have my axis right here, and I want to look perpendicular to the axis, and I want to look in line with the base of the object right there, so I get my stretch out line all the way along there. I'm not going to leave much space between the views here because I'm really going to be caught for space. I'd say I leave about 5 or 6 mil maybe, and I'm going to use the shortest edge of the object, which is number 1, as the seam. So right there, that's the first line on the development there, and that is number 1. If I was folding this object and I need to ensure that I'm looking at the inside of the object after folding, well, I'd cut it at point 1 and I'd unwrap it around, and I'd then go to 2, 3 and all the way around. So let's just go ahead and do that. The distance is here. That is the true distance along the cylinder's path from 1 to 2 and 2 to 3 and so on. We don't take them from down in the plan. So 1 to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and perfect spacing. It's just staying on the page. The one thing I want you all to just make sure you do now is extend that on a little, is number. So that starts at 1, it goes to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it has to finish where it started for a round object that goes all the way around. You can't stop at 12. If you stop at number 12, you're missing a section. So there we go, we finish at number 1. I'm going to just start and finish the same at the same point. So I'll take parallel to the base and I'll just stretch that all the way out there. This is getting really awkward now for me. I'm on the small A3 page, but we'll keep going. Parallel to number 1. Yeah, I'm getting caught in my stand here now. Parallel to the edge 1 and to the main axis of the object, out here to finish at number 1. I'm going to take all these lines nice and light. There's no fold lines, of course, in this cylindrical object, or there's an infinite number of fold lines depending on what way you want to think about it. So I'll just keep everything light. All of these lines right now are parallel to the axis of the object. Now, the base of the object, or the base of the development is just one single straight solid line. But the top of the development changes because it goes from point 1 here, it stretches all the way out to point 7 here, and it goes, so it's going to be going out to 7 and back in to 1. I'm going to just take the point I know first of all, as I just said there. Number 7 is the longest one, longest edge right there. So there's number 7. All other edges can be just projected straight off the end of the line, because all lines are true lines. So you can add as much numbering as you want and take as much time as you want to do this. I'm going to go through this relatively quickly. That's number 2 and 12. So it goes on and strikes number 2, and it goes on and strikes number 12. That's 3 and 11, so it strikes number 3 and 11. 4 and 10. 5 and 9. 6 and 8. And there we go. All of the points on our development. Freehand them in. And there we have our development. That's the drawing finished. There's nothing else asked of us there. There's quite a bit of understanding, I suppose, needed, and a bit of visualization needed to be able to, first of all, realize what you're being asked to do over here, and realize and understand how to actually find these correct widths for 410, for 311, and so on, finding the correct base profile. And then finally, I think that probably the easiest part of the question is part B there, is just finding your development. As long as you're used to doing developments of cut cylinders, well, if the cylinder was lying as normal and it was around on the XY line, no one would have an issue with doing it. But it's just when it's turned at an angle like this, we need to make sure that we understand the methods, and we need to have a good understanding of looking perpendicular to the axis as our viewing direction, not just always in line with a base, which is not really the right way to learn it. In line with the ground only works if the axis stands straight up from the ground. Now that is the drawing. That is 2004 Junior Cert Higher Level question 4 on developments, and I hope this helps.